Hello world, it's me. I have a project going on in the back burner to create a reproduction system boards used in the Intel Intellect 8 system. And if you're interested in the project only, skip ahead to the last few minutes of the video. I'll put the exact time down in the description. But first I wanted to give a little background on the Intellect systems and why, at least to me, this project is worth the effort. After Intel introduced the 4004 in 1971, and it seemed like they just might be onto something, Intel developed their 4004-based engineering prototype boards. Now remember, the microprocessor and some of these support devices like the EEPROM didn't even exist before this time, so manufacturers were facing a whole crop of engineers that needed education and training and experience in designing around their specific microprocessor. So application notes, engineering examples, prototyping hardware, the engineering samples that they sent out, and the full suite of development tools and software was going to be critical for the success of any microprocessor platform. So the very first of these engineering prototype single board computers that Intel put out were the SIM4-01 and the SIM4-2. And the SIM4-1 was about 6 by 8 inches, had a 72-pin edge connector on the bottom, and it provided the programmer with 320 nibbles of RAM. So on the 4004, the program RAM was in nibbles, and it had 4 1702A EEPROMs, so it had a kilobyte of ROM. This is the SIM401. You can see the 4 1702A EEPROMs here in the upper left. The 4004 is down here in the bottom left, and the 4001 RAMs are just to the right of the 4004. So this was essentially the first single board computer. Apply power to this thing, fire it up, and you can start putting code in. The SIM4-2 was much more capable. It had 1280 nibbles of RAM, and it had 16 1702A EEPROMs for 4K total of ROM. And it was a much larger board. It was 10 by 12 inches. It had dual 86-pin connectors on the bottom, and nearly every signal on the board came out to these bottom edge connectors, allowing this to be a development workhorse. You could probe almost any signal that you wanted. For either of these boards, there was the companion MP7-03 EEPROM programmer board, and that was for programming 1702A EEPROMs, which was essentially the only EEPROM family that existed at that time, since the EEPROM had just been invented the year before. To create a turnkey system, these boards could be mounted on either the MCB410 or the MCB420, depending on which SIM4 card you had. MCB stood for the Microcomputer Connection Board, which in some of their documentation they also called the System Interconnect and Control Module, which sounds more like a NASA term. So I think they settled on the Microcomputer Connection Board as the product name and gave it the MCB title. So this is a complete system. It's got the MCB4 base, the EEPROM programmers in the back, and the SIM4-1 is in the front. Both of these photos are from Mustafa Katie's Intel-Vintage Info website. And I'll put a link to this site in the description because it's the world's leading clearinghouse for Intel information. And if you're looking for any files on reproduction boards, he has created a nice collection of boards, and the files are available for download on his site. So if you want to make something like the SDK80, SDK85, or many of the other critical Intel boards, he's got the files you can just download and have them made. For the 8008, the MCS8 and the SIM8-1 board quickly followed and were out by the end of 1972. This is the SIM8-1, and just like the SIM4 family, there was the more powerful SIM8-02. Now everyone has a dream machine, and truth be told, these SIM4 and SIM8 machines are my dream machine to ever actually own or at least get to program. The next year, in 1973, it looked like the microprocessor just might catch on, so Intel introduced their 4004 microcomputer development system called the Intellect 4. Now, the purpose of a development system is to support microprocessor hardware and software development, specifically for that target platform. As I mentioned before, this was all new to engineers, and they needed as much support as possible. So Intel created the Intellect 4 and its support software, including a 4004 assembler and a resident monitor. Compared to the SIM4 boards, this was extremely refined. It was in a nice cabinet, it had a front panel control, teletype interface, paper tape reader interface. It was what we would look at and consider to be a full computer. Just like we would look at an Altair or an IM6 and say, yeah, that's a full computer. The Intellect 4 had 4K of program RAM, 320 bytes of data RAM, and up to 4K of ROM. It was expandable I/O for dozens of 4-bit I/O ports, and it also included the nifty little 1702 programmer on the front. You connect this up to a teletype or a terminal, a paper tape reader to get your code in, and you had a complete 4004 development platform. Internally, it was a 16-slot backplane with 100-pin edge connectors, had interface cards for the front panel, had a CPU card, had up to 4 RAM cards, 4 ROM cards, and 4 I/O cards. And then it also had a card to support the programmer. So the most basic system would have 11 open slots where the user could expand their memory, their I/O, and create their own prototype cards. But the motherboard slots were dedicated, so you could only have 4 of each of those cards for the RAM, ROM, and I/O. They also had the Intellect 4 Mod 40, which was the same sort of setup for the 4040 microprocessor. And if you needed to upgrade or you wanted to upgrade to the 4040 version, you could send your Intellect 4 back and have it upgraded to the Mod 40 version. So there was this Intel Imm6-28 conversion kit, which swapped out the 4004-based CPU card for the 4040 CPU card, swapped out the memory card, swapped out the I/O cards. And with the 4040 system, you had some new features, including the addition of a program edit function in the assembler. When the 8008 came onto the scene, the system modified with a new front panel and a new backplane and was rebranded as the Intellect 8. Likewise, there was soon the Mod 80 version for the 8080 processor on the Intellect 8. The Intellect 8 had the same general concept, and it could have up to 16K of memory compared to the 4K of the Intellect 4 or the Intellect 40. Note that this was the total memory which was being shared between RAM and ROM in these systems. When you ordered a base system, it came with 10K, of which 8K was RAM and 2K were ROM on one of the Imm6-28 2K ROM boards, which had 8 pages of 1702A memory. Notably, they had an extremely interesting, potentially wasteful, but very flexible memory configuration where the entire ROM and RAM memory spaces were overlapped. It's crazy by today's standards, but at the time it was a necessity of being a development system. And maybe someday I'll get into more detail of how that ROM and RAM overlap. With the 8-bit Intellect system came additional features. Most notably was an actual text editor and a macro assembler. As we can all appreciate, a text editor was a big deal on this. Like the 4-bit system, the 8-bit Intellect 8 Mod 8 had an upgrade path to make it a Mod 80, where you could purchase and swap out the 8008 processor card, swap out the I/O cards, and get updated firmware. But even with all of this swapping, the 8080 system would still be limited to that 16K of total memory, and in part that's due to the hardware and design limitations of the backplane and the memory cards. But at least with the Intellect 8 Mod 8, there was enough planning ahead by Intel that you didn't have to send the unit back for factory modifications like it was required for the Intellect 4. With the 8, the upgrade kit could be installed in the field just by swapping out these boards and the resident monitor PROMs. Now keep in mind that all of these Intellect systems and different processor cards were introduced in the same year, 1973. In fact, the Intellect 4 and the Intellect 8 were announced at the same conference that summer. So the differences in these systems were very minimal. Changes were made on an as-needed basis, and any improvements were just purely evolutionary. And there were common components used whenever possible. Now for a time reference, the Intellect came out in 1973, the Mill Mod 8 in 1974, the Mark 8 was also in 1974, and the Altair 8800 would come out in 1975. So you can see where these machines that are all very similar, and to help you remember where we were in 1975, think of, the fall of Saigon, the movie Jaws came out, the Betamax VHS decision we all had to make, and the Apollo-Soyuz link-up. The 8-bit Mod 8 and Mod 80 systems had their own I/O cards. So for a Mod 8, you would have the Imm6-28, but you'd have the 61 for the 80. They also had just pure output modules, which were the Imm6-62 for the Mod 8 and the 63 for the Mod 80. So if you look at the numbering here, any Imm4 is for the 4004 and the 4040 systems. Any Imm8 is for the 8008 and the 8080 systems. So here's a brochure for the Intellect 8 system. Has the RAM card up here in the top left, the PROM card in the front left in front of the extender board. And on the right side, there's the 8008 CPU card in the front, the I/O card, and the prototyping card on the top right. In addition to the Imm4 for the 4-bit systems and the Imm8 for the 8-bit systems, there were also cards numbered as Imm6. And Imm6s can be used in either the 4-bit or the 8-bit system. So this goes back to the commonality that I was talking about earlier. And that commonality turned out to be a lot of the big restriction on hobbling the capabilities of the 8080 system. So in this brochure, the CPU is the 8008. Most likely the PROM card is an Imm6-26. The RAM is the 6-28. The I/O is the 8-60. The prototype card was the 6-70, and the extender is the 6-82. So the ROM, the RAM, the prototype, and the extender are all 6- numbers. So they could be used in either the 4-bit or the 8-bit system. Now, evidently, the Imm6-76 PROM programmer card, which, since it's a 6, it also is used in either system, for some reason, it didn't make the photo shoot for this. But then I guess the front panel control card isn't shown either, so maybe those were just considered to be part of the box. The minimum card system that I'm making for my reproduction is the 8008 CPU, the 2 memory cards for the RAM and the ROM, the I/O card, and the backplane card. So back to the story of the Intellects. Since all of this hardware came out pretty much simultaneously, or at least in rapid succession, and because there was an emphasis on backward compatibility and commonality, there were no dramatic improvements in the progressive systems. And as such, the Intellect 8 and the Mod 80 in particular had real limitations, especially in that memory. Still being limited to that 16K of memory, and it was all 100% overlapped between RAM and ROM. And for all the systems, most of the configuration was hardwired with dedicated backplane slots. So you would plug a RAM card in, and that would define the address for that card, depending on which slot you plugged it into. And meanwhile, processor technology as a whole was changing at light speed. So very quickly, all of these systems became obsolete. The SDK-80 came out in 1975. So again, this is just the next year. And that put development and training in the hands of the masses. So now instead of having one of these complicated systems, you could just have an SDK-80. And for the most part, you could do a lot of education, training, and system development using the SDK-80. So by 1976, the Intellect 4 and the Intellect 8 development systems pretty much entirely gave way to the MDS-800. And if we look at a 1977 microcomputer systems catalog, only the MDS-800 and the Intellect 4 are listed as development systems. So the Intellect 8 at that time went completely away. The MDS-800 took its place. And for the stragglers, there was still the Intellect 4 for people that were still doing 4-bit stuff. The next year, 1978, both of those are gone from the catalog, and everything has moved over to the MDS Series 2, like the 225. So the MDS-800 really only showed up in 1 or 2 annual catalogs. And it's pretty amazing how short a lifetime of these development systems really was, and it's no wonder that they're hard to find today. Production of these only lasted for a year, 18 months, or 2 years. And at the end of that period, it was just completely obsolete. The IMM product identifier in the cards I didn't mention, it stood for Intel Microcomputer Module, or possibly Intellect Microcomputer Module. At least that's what I've inferred from their data sheets. I've never actually seen it explicitly defined. Either way, the naming convention is stretched to its limits with the IMM4-90, which was the high-speed paper tape reader to support the Intellect 4 systems. And while it's not a board like the others, I guess it's still considered a module, since modules can come in all shapes and sizes, and it was just something you could sit on top of the Intellect 4 system. Now, the Intellect IMM4-90 paper tape reader is not to be confused with the IMM8-90, which was offered only with the Intellect 8, or not to be confused with the MDS PTR paper tape reader, which was introduced with the MDS-800. And finally, none of those should be confused with the Intellect high-speed paper tape reader, which was offered with the MDS Series 2. And of course, all of these paper tape readers are exactly the same, but they were individually branded for each development system. That quadrupled the selection of paper tape readers that Intel had to offer, I guess. So, never let the customer know they're buying last year's model. Nonetheless, these are all just private labeled Remex readers anyway. As an interesting side note, if you look at these 4 data sheets, after publishing the same sales sheet dozens of times under 3 previous models, in the 4th listing, Intel had a typo in the feature headlines, and they list the data transfer rate as a blistering 2,000 characters per second rather than the actual 200 characters per second. So the SIM and Intellect systems were development hardware. And whether or not Intel actually believed that it was going to be a good idea to release the boards as a separate product, these IMM boards turned out to be a really big deal because Intel introduced the Barebone systems. Because now, in addition to the development systems, Intel was finally on a pathway that would eventually lead to the Multibus standard and the introduction of the ISBC series of hardware. These IMM cards were marketed and sold as industrial controller Barebone systems. A Barebone system contained the same rack internals, but it was in a rack mount chassis without a front panel, no front panel controller, no EEPROM programmer. The system was basically a chassis with a power supply, the backplane, a CPU card, and just enough support cards to provide memory and minimal I/O. But these Barebone systems were pivotal in the acceptance of off-the-shelf, standardized industrial control systems. Now, without a doubt, Prolog and MOSTEC and others in industrial control were right on their heels. But in my mind, they never displaced Multibus as the standard industrial controller workhorse for high-end systems. In 1976, the 8080 Barebone system was still going strong. They still had the Intellect 4 and the Intellect 8 in the 76 catalog. But the most exciting thing was the introduction of OEM systems, which at that time only included the SBC 8010 single-board computer. And the 76 catalog says the SBC 8010 is a member of Intel's complete line of OEM computer systems. But it should be noted that the entirety of the OEM computer systems in the 76 catalog consists of 2 pages, and they were both for the 8010. So there was nothing else listed in that catalog as this complete product line. But we know that they had other Multibus cards that came out because the MDS 800 was based on Multibus. Or maybe Intel just didn't believe in it enough to make the effort. I don't know why Intel was still passively marketing the SBC products. The SBC products were a success in spite of themselves. So Intel completely haphazardly fell into the microprocessor industry just 5 years earlier. Now, despite their lackluster effort, they were setting the stage for industrial microcomputer revolution with the introduction of Multibus in the MDS 800 and the SBC 8010 family. However, they hadn't even branded these cards as ISBC yet. They were just SBC and not the Intel SBC. So they hadn't even branded them as ISBC series yet. And it wasn't even branded as Multibus either. In the literature, it was just called MDS card format. Or even less eloquently, the PC board format and power compatible with Intellect MDS. It wouldn't be until 1977 when Intel finally introduced Multibus as a trademark name. And presumably the name Multibus was to slight DEC's Unibus. But if the one-upmanship naming wasn't intentional, then the Intel 1977 marketing team was even weaker than I give them credit for. Because branding-wise, Multibus is a great one-upmanship of Unibus. As a side note, the first time I could find Multibus used by Intel was in 1977. For example, this application note where Multibus is given the unregistered trademark designation TM. And I'm only bringing this up because Intel didn't apply to register the Multibus as a trademark until July 27th of 1979. So that's July 27th of 1979, at which time on their application they listed the first use in commerce as July 10th of 1979. So earlier that month, when we've seen that in 1977 catalog and datasheet. But don't bother taking them to task with the USPTO because the trademark was abandoned in 1987. And now it's officially listed on the USPTO as a dead trademark. So quite amazingly, Multibus as a trademark only lasted for 8 years. As another little side note to show that this was never a one-horse race, in 1977, Fairchild's quirky little F8, the 3850, was the world's leading microprocessor in terms of sales. So in 1977, Fairchild's F8 had the market. All right, with that introduction of where the Intellect development system fits into history, I hope you can appreciate that they had a significant impact on the microprocessor world, and having one would just be plain cool. But unfortunately, no, I'm not going to be showing you an Intellect 4 or an 8 because surviving units are very scarce and reserved for the select few, and they're nearly unobtainable for us mere mortals. So unfortunately, I won't be casually holding up some vintage Intel IMM cards as if every grandmother has one. And that's actually the purpose of this project, to reproduce this IMM hardware that was used in the Intellect 8 and the Barebone 8 systems. Well, I do have something that is close. Hold on. This is an advertisement for the Intercolor 8001, which was a system made by Intelligent Systems Corp down in Georgia. So this was a smart terminal. It was a kit. You could buy it for $1,400 as a smart terminal, and then for another $1,300 it could be upgraded into a personal computer. And this is a RAM card out of that machine. And these are somewhat readily available. You can find these occasionally on eBay. And the going rate for this is about $100. So compared to any of the Intel IMM boards, this is a great deal. Now, it's not exactly a coincidence that these intelligent system cards are the same form factor as the original Intel IMM cards, because at least what I've been told, they're semi-compatible and in fact were based on the Intel IMM system. So if somebody out there has schematics for the Intercolor 8001 or some inside knowledge, then we can resolve this issue once and for all. Otherwise, we're going to have to wait until I get my IMM cards up and going before we can see if this card is fully compatible. If we look at this size-wise, so if we say that this were an Intel IMM card, that's the size-wise of it. This is S100. So obviously you can see same 100-pin connector, just a little bit bigger. So S100, IMM. This is the bus out of Intel's UPP, which was their Universal PROM programmer. So you can see it also is very, very similar, a little bit wider. Here's STD, so this is an STD card. And then back here I have a Multibus card. So here's a Multibus card. So that's an example size-wise of these different cards. So back to this one. The moral of the story is that the Intellect series was used as a starting point for many other systems. And the pared down OEM Barebone systems had a lasting legacy that we probably won't fully ever appreciate. A few years ago, I purchased the reproduction card set from my buddy Charles up in Canada for the Imm6-28 system. So this is the 8008 board, and I also have the 8080 board. And so this also was a derivative of the IMM, have a lot of similar concepts. And I did several videos at the time. You look back to video number 19 or my mill playlist if you're interested, because the mill system has a lot in common with the Intellect 8, and it's actually learning the mill system is a good starting point for learning the Intellect 8. At the time I was thinking that this would appease my need for an Intellect 8, and it did for a while, but the need returned when I saw somebody in one of the Facebook vintage computer groups who was so very fortunate to have a Barebone system just fall into their lap with any idea of what it was. And they were posting photographs and does anybody here know what this machine is? And that kind of a lead-in so often leads to, at least in me, some pretty deep feelings of envy. So that rekindled the need for a system based on the Intellect 8 boards. So after procrastinating for some amount of time, and that's measured in years, I finally started the schematic capture and the board layout to create these reproduction Barebone systems. At the end of last year, I laid out the Intellect Mod 8, Mod 80 backplane, and the Intellect 8 backplane has the same form factor, same connections, same size as the Intellect 4, and any of the IMM6 cards will work in either backplane, but there are differences between the 4 and 8 processors, so this backplane is only for the 8. It would take a different backplane to work with the Intellect 4 system. And then I also have laid out the Imm6-28 RAM, which again can be used in either the 4 or 8 system. Here's a system model with the motherboard. So on this motherboard, the far right-hand slot is for the EEPROM programmer card. The 4 to the left of that are for I/O cards. The next ones are for the ROM cards. So let me put the ROM cards in. So here's the 4 ROM cards. The next are for the RAM cards. The next card is for the CPU. The next is the front panel card, and then there's an interface card in front of that. So this is the full system when I eventually get all of the cards built and installed. And as I showed you, I have the motherboard and the RAM card back from the shop. The ROM and the CPU card are ready to submit to the shop, and then next up I have the I/O card that I have to make. There's the output card and the I/O card. The I/O card will give me a fully functioning Barebone system because I can hang a terminal on it with that I/O card. Then, depending on the level of interest in this project, I may come back and do the 8080 CPU card for the Mod 80 before considering any of the other cards like the front panel controller or the PROM programmer. Okay, well that's it for this video. I just wanted to give you a heads up to see if anybody's interested in this system and these reproduction cards, depending on how many other interrupts come along. I hope to get enough of the components made this spring so I can get a complete bare board system up and running before May. However, there's a good chance of things dragging into the fall because, like everybody, we've had 2 lost summers of COVID and we need to make up for that. So I don't plan on being home once the weather breaks this spring. I plan on being someplace else all summer long. That's it. And as always, this channel is fueled by subscriptions, likes, encouraging comments. And if you're interested in seeing more about this project, let me know. Otherwise, I won't bother making videos of it. Of course, you can always contact me using the email address on the sbc85.com website. Alrighty, I will talk with you later. Bye-bye.